All right. Anyway, going over this, we had our number 54. Given a triangle ABC is isosceles with AB and BC equal. If measure of angle B is 30 degrees, then find measure of angle A. So first thing I would do is draw a diagram. So on this one, we're going to draw the diagram. And we know which one should be the vertex because they told us that AB and BC are equal. That means that B, the point where those two intersect, must be our vertex angle. So we have triangle ABC, something like that. They told us that angle B is 30 degrees. So up at the top, can label that as 30 degrees. These two bottom angles that are across on the sides that are congruent must be congruent as well. So we have a total of 180 degrees for all the interior angles of a triangle. So first thing we're going to do is subtract off the 30 degrees that was given to us. So that brings us to 150. And then that 150, we have to split between angles A and C. So divide 150 by 2. And when you divide 150 by 2, you get, is that 75? So both of those bottom angles for A and C would be 75 degrees. On the next one, 55, given triangle CAT is isosceles with, so again, they told us it's isosceles, they're telling us which sides are equal. This time we have CA and AT are equal. So A, the common one, has to be our vertex angle. So I'm going to draw it again. This time I'm going to draw it with A at the top, and then the bottom two angles will be C and T. If measure of angle C is 40 degrees, so this one down here is 40 degrees, then find the measure of angle A. Well, if C is 40, C and T are the two base angles. They have to be congruent. So T also has to be 40. Together, C and T add up to a total of 80 degrees. So to find that angle left at the top, we're going to subtract the 80 from the total of all the angles, which has to be 180 for a triangle. So that top angle is going to be 100 degrees. Now, again, I didn't draw it to scale, but that top angle would have to be 100 this time. On 56, name the corresponding parts of the following triangles. So on here, they showed two angles in each triangle. Now, if we were to subtract the two angles that are here from 180, we'd be left with 77 degrees for angle B. And then on the other triangle, if we subtracted angles E and F from 180, we'd be left with 41. So all the angles are the same. We need to match up all the corresponding parts, it said. So we have angles A and angle D would be corresponding. Angle B would correspond to angle E, and angle C would correspond to angle F. And I'm just using an and symbol there in the middle. That's all that symbol is an and symbol. If you want to write out the word and, that's fine. But that's matching up the angles. Again, if you wanted to put a comma in between them as well, that's fine too. The sides you also should match up. So for the sides, I'll just write out with commas this time. Side AB would match up with side DE. Side BC would match up with side EF. And the last one, side AC and side DF. So that's how they would correspond. All right, on 57, find the value of Y. So again, all the angles have to add up to 180. So we're going to have 180 equals, and then we're going to combine all these values. So I have the 3y plus 40. I have the 2y plus 40. And we have the 2y minus 5. All this is addition and subtraction, so we can just go straight to combining like terms. We don't have to worry about the parentheses at all. So we have a 3y, a 2y, and a 2y for a total of 7y. We have a positive 40, another positive 40, and a negative 7 for a total of positive 75. And now we can solve. So we have to bring the 75 across by subtracting 75 from both sides. That gives us 105 equals 7y. And then we have to get rid of y by dividing. So divide off 7, I meant. So 105 divided by 7. Let's see, is that going evenly and all? Yeah, that's going to be 15y. And that's it. On the next one, 58. So this one a little bit different. We have two angles that are inside the triangle. We have one angle on the outside of the triangle. This is using the idea of an exterior angle. The exterior angle, which is this one, so this is an exterior angle, has to be equal to the sum of the remote interior angles. So these two that are labeled are going to be the remote interior angles. So we have 7a plus 50 equals, we're going to take the other two and add them together. So 70 minus 3a plus 2a plus 80. On the left side, we can't do anything with it just yet. It's going to stay 7a plus 50. On the right side, combine like terms. So we have negative 3a and a positive 2a gives us a negative 1a. 70 and 80 combined together to give us a positive 150. I'm going to go ahead and bring the 1a over to the other side by adding 1a to both sides. That now gives us 8a plus 50 equals 150. Then we're subtracting 50 from both sides. Leaves us with 8a equals 100. And then finally, we're going to have to divide off that 8. So again, we had 8a equals 100. We're dividing both sides by 8. So a is, that once, we have 2 left over. That's going to be 12.5. Now, is that our final answer? No. So on this one, we have to be careful because we solved for A, but they said find the measure of angle TRI. So TRI is this angle over here. We have to take that answer of 12.5 and plug it back in. So we get 7D minus 3 times 12.5. Make sure I didn't make a mistake because it seems odd that they'd give you a decimal answer there. No, that's what they got as well. All right, so let's do this other part of the work up top. Change my pen just so you can tell it's different. 70 minus 3 times 12.5. 70 minus 3 times 12.5 is going to give us, let's see, that's 37.5. And then subtract off the 37.5, which is going to give us 32.5. Did I do that right? Yep. All right. Moving on to 59. So again, that's for 58. That was our final answer for that angle. All right. For 59, Raymond threw a ball that bounced up at an angle of 2x plus 4. What is the value of x? All right, well, it's showing us that we have a 90-degree angle with the wall here. And then these two angles together must add up to 90 degrees. So they're complementary. 90 equals 3x plus 6 plus 2x plus 4. Combine like terms, 3x and 2x gives us 5x. 6 and 4 gives us 10. Subtract off 10 from both sides. That leaves us with 80. And then divide both sides by 5. And we get 16 for x. Again, final answer that they wanted here was just what is the value of x. So 16 is our final answer. All right, going on to 60. we had some parallel lines. So it told us segment AB is parallel to segment CD. That's what that symbol is. It means parallel. So now that we know these two lines are parallel, I'm going to go ahead and label it on here with our other parallel symbol. Find measure of angle ABC. So ABC. So they actually want this angle here that's not labeled with anything. Now, before we can find that angle, they gave us two other angles. The two angles that they gave us are called what type of angles? So they're inside the parallel lines, but they're on opposite sides of the transversal. These two are alternate. They're alternate interior angles. Would you mind grabbing the phone for me? Oh, yes. Ashley? All right. So again, those two angles, those are alternate interior angles. They're in opposite sides of the transversal, making them alternate. They're inside the parallel lines, that makes them interior. So alternate interior angles have to be congruent. So on here, we're going to set those two equal to each other. So we have 10x minus 30 equals 5x plus 5. Again, we need to get things over to the same side so that we can combine like terms. So we're going to get the 5x over by subtracting it. So minus 5x brings us to 5x minus 30 on this side. Bring the 30 over by adding it. Add 30 to both sides. That's now 5x equals 35. Divide 5 from both sides, and x is 7. Now, we can plug it in. You can plug it into either equation. You should get the same answer. If you want to plug into both and make sure that you got the correct answer, that's fine too. I'm going to plug into the one that looks easier. So this one is 5x plus 5. I'm going to plug into that one. 5 times 7 plus 5. 5 times 7 is 35, plus 5 is 40. So this angle is 40. Now, looks funny because that definitely looks obtuse. So since I got a value that doesn't make sense for the diagram, I'm just going to go ahead and try it in the other one and make sure that I got the same value. So 10 times 7 minus 30, that'd be 70 minus 30, which is 40. So this diagram must just not be drawn to scale. So I got 40 in both of these positions. The angle that they want me to find, though, is not equal to those. How is the one that they want me to find related to either of those two values? So when we have parallel lines, we either have angles that are congruent or angles that are, so that's an S. Supplementary. Yeah, so supplementary angles that we have, these two angles have to add up to 180. So to find the angle they want us to have, we're just going to subtract that 40 from 180, and that leaves us with 140. So our final answer here, again, what I did for that final step, I'll write big over here too, just in case. But again, 140 degrees, that's our final answer. So diagram wasn't drawn to scale, and sometimes it won't be, but that is the correct answer. All right, 61 and 62. On this one, it says use segment addition postulate to solve for x. So all segment addition says is that when you have two segments together that are on the same line and they're next to each other, they have to add up to give you the total for that length of the whole line segment. So on here, segment AB and segment BC, when added together, should give you the total length of segment AC. So we need to write an equation that does that. So we have x plus 10 is equal to 5 plus 2x plus 6. So x plus 10 is the entire line. The 5 is AB. The 2x plus 6 is BC. Combine like terms. So the left side isn't changing yet. 5 plus 6 is 11. Now we need to get values to the same side. So I'm going to go ahead and move the x over to the other side by subtracting it. That gives me 10 equals x plus 11. I'm going to bring the 11 over by subtracting it. So x is equal to -1. Now, if you want to double check and make sure you did everything correct, you could plug it in and see what the values are. So if I plugged in -1 to this equation, -1 plus 10, that's 9. Up here, -1 plugged in here, I'd have 2 times -1, which is -4. Sorry, not -4. I lied. 2 times -1 is -2, plus 6 is 4. So I have 5 and 4, and 5 and 4 do equal a total of 9. So that is correct. Okay. Let's do the other one. The other one, essentially the same idea. So we have used segment addition postulate to solve for x. This time they gave us the entire thing was 39. They gave us the two smaller pieces, 9x plus 7. And add to that the other piece, which was a -3x plus 20. Combine like terms. 9x and -3x gives us 6x. 7 and 20 gives us 27. First, bring that 27 over to the other side by subtracting it. So that's going to give us 12 equals 6x. Divide both sides by 6. And x is going to be 2. And again, if you want to check it, you can plug it back in and see if those two pieces add up to 39. All right, so that was 62. The last problem we're doing today is 64. So on 64, in the diagram, triangle ITP is congruent to triangle NGO. Find the values of x and y. So on here, this statement that they gave us up at the top is what's telling us how they're congruent. So they didn't give us any actual angle measures or lengths of sides on the other figure. So again, in order to know how they match up, I have to use that statement. So for NG, they have both an x and a y in that equation. Well, I can't solve for both an x and a y at the same time. So I can't solve for that one first. For angle O, they gave me an equation or expression that has just a y. So we can use that one. So we're going to use this equation for angle O. And if I look at the statement, O matches up with P. They're in the same position. So 40 is in the same spot as angle O. So 40 equals 6y minus 14. Add 14 to both sides. Gives us 54 equals 6y. Divide off the 6. And we get 9. So y has to be equal to 9. Now we can solve for the other piece. So for, change my color one more time. For this piece, which is between N and G, if I look up here at the top, N and G are the first two letters. So another triangle, I and T are the two that we're using. So I'm saying that one equal to 7.5. So 7.5 equals x minus, got a little ahead of myself. Let me erase that. So x minus 2 times y, which y we already know is 9. So now multiply that piece out first. 2 times 9 is 18. Add it to the other side to get x by itself. 18 plus 7.5. That's 18 plus 7.5 is going to be 25.5 for x. And in the problem, they only ask for the values of X and Y. So that's it. Those are our two answers. Any questions on those?